Okay, let's try problem 5.24. A 23 kilogram child goes down a straight slide inclined 38 degrees above the horizontal. The child is acted on by his weight, the normal force from the slide, and kinetic friction. A. Draw a free body diagram of the child. Okay, so let's go ahead and do that. So A. So let's just draw a picture of what's actually going on first. So we have a slide. We'll call this the slide right here. And then we have a child. It's represented by, I'll represent that by a box. Okay, so we know that this is angled at 38 degrees. And the child is acted on by his weight. So the weight points straight down, right? The normal force from the slide, which is perpendicular to the slide. And kinetic friction. So kinetic friction is going to act parallel to the slide. Call it F sub k. Okay, so now that we have a picture drawn, let's go ahead and draw our free body diagram. So to do this, I'm actually going to tilt my axes like that. So this is going to be my x, and this is going to be my y. And so now if we draw these components in, right, the normal force is going to be right along the y-axis, which is nice. The kinetic friction, force from friction, is going to be right along the negative x-axis, F sub k. And the weight is going to be straight down still. Okay. So this is going to be my free body diagram. Now part B, how large is the normal force of the slide on the child? So to find the normal force, we want to know the component of weight, the component of the weight that points in this direction, right? And so this component of the weight, we'll call it W sub y, is perpendicular to the surface. So it's the part of the component of the weight that is perpendicular to the surface of the slide. So I'm just going to redraw this triangle over here. So this triangle right here, right? So if I drop that line right there, we know that this has to be 90, right? Because this right here is a 90-degree angle. And so if this is theta, that means that this has to be 90 minus theta. Right? Because there's 180 degrees in a triangle, so this is 90, and this is theta. This has to be 90 minus theta. But that also means that this angle right here, let me change colors real quick, has to be theta. And that's because that this right here is a right angle. And so if we have this part of the angle being 90 minus theta, that means that this has to be theta over here. So we know this is theta as well. So I'm going to redraw this triangle over here. So this is W sub y, right? The y component of the weight. And then we have the full weight. We'll call this W. And then we also have some component that points along the slide, W sub x, which we're not worried about. And we know that this has to be theta. Okay, so now to solve for this, right? We know the adjacent side and we know the hypotenuse. The adjacent side is W sub y, which is, we don't know W sub y, that's what we're trying to solve for. But we know W. So to relate this, all we have to do is cosine theta, right? Because SOHCAHTOA, sine is opposite of hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So cosine is the adjacent, which is W sub y, over the hypotenuse, which is W. So cosine of theta is equal to W sub y over W. Now to solve for W sub y, all we have to do is multiply W to both sides. So we're left with W cosine theta is equal to W sub y. Now we're just given the mass of the child, so we have to convert that into the weight. So to do that, all we do is weight is equal to mg, right? So this over here just becomes, right over here, mg cosine of theta. This is equal to W sub y. And we know all this, right? So this is equal to the mass of the child, which is 23 kilograms, times gravity, which is 9.8 meters per second squared, times the cosine of, 38 degrees. So when you plug this into your calculator, this actually comes out to 180 newtons. So that's going to be the component pointing this way. But that's the same thing, it's just in the opposite direction as the normal force. So 180 newtons is going to be our normal force. And that's problem 5.24.